The first type of sorting we're going to look at is selection sort. On Moodle, there's an explanation as to what this means. This is called big O notation. So if you look at it, if we have like O1, that just means that this algorithm is always going to execute the exact same thing. On is determining the performance based linearly. So if 1 increases, the time increases. On squared, it's directly proportional to the square of the size of the data set. So if you have a data set that's size 4, the time is going to be 16. So that's just something to think about. So what I'm going to do is I'm going to come back in our code and I'm going to change it to say selection sort. So then that way we kind of know which is which. Then don't forget to change this up here to selection sort. Okay, so selection sort is an incremental approach. So the way that selection sort works is it does swapping. So it takes this first number, and this is what's selected right now, and then it compares it against all of the numbers in black. It finds the lowest one, which is 1, and it swaps their spaces. So now 1 is in the front and 4 is in the back. Now 1 is done, so it just stays there like that. Now 2 is selected, and it compares 2 against the remaining numbers in black. It is lower than all of those, so it stays put. Now 5 is selected, and it compares against 4 and 3. 3 is lower, so they swap places. Now 4 is selected. It compares against the remaining numbers, which is 5. And since 4 is lower, it stays where it is. And since 5 is the last number, it is now the largest number and stays where it is also. So that's just an overview of how selection sort works. So basically the code is going to be written exactly like how you just saw. So selection sort is based on swapping a number for a number. Okay, so our selection sort is going to take in the array. So what we're going to need to do with our code for selection sort is we're going to create a for loop, and it's actually going to become a nested loop. So our outer loop, what it's going to do is that example that we just did, it's going to take us on steps. So the step is from step 1, 2, 3, 4, and then test that last number. So that's what our outer loop is for. The inner loop is going to look at the remainder of the array. It's also going to pick the smallest one and swap if necessary. So I'm going to go ahead and I'm going to set up 2 variables here. So we're going to create integer min and integer min index. And we're going to start our loop. So our first outer loop is going to be for int I equals 0. I is going to be less than array.length, and we called it a up here, so it's a length because we don't need to go longer than our array. And then we're going to do plus plus I. Remember, there's no semicolon at the end of that. We're going to open our bracket. So now what we're going to do is we're going to set our min value is going to be whatever is in AI. So this is going to keep going through, and it's going to say whatever is in spot 0, is in spot 1, is in spot 2, and save it to min. But for our code, we also need it to remember our index of where we are. And that's also going to be I. So this is the content, this is the location. So now that we're going through the loop and we're going through each item, what we want to do is we want to find our minimum. So I'm going to come down and I'm going to create a new nested loop. And it's going to be equal to I plus 1. Okay. We're going to go until the end of our array. and then plus j. Okay, and this is to find the minimum. So to explain that, remember if I is 1, or if I is 0, so we're looking at spot 0, we want to compare it against location number 1. So be 0 plus 1, so this is comparing against location 1. So now, what we want to do is test the code. So don't forget to put in your brackets for your new for loop. So we're going to test it. So if aj, x of j, is less than the minimum. So remember, we already set the min to be spot A0. So now, if A1 is less than the minimum, we need to know that. Okay. Test two numbers against each other. Okay, so in our if code, if it is smaller, so if it's like our original thing where 2 is less than 4, it's going to say min equals aj now. So we're swapping content, and we're going to swap the location also. So that's swapping the contents, and now we also need to swap the location. So outside of your if statement, actually outside of that inner for loop, because now we've already discovered that it's true. So come on down, and we're going to say a min index, we'll drop max index because we're so used to using that, equals ai. So this is our swap, the index. And now ai is equal to the min. So this swaps contents. And that's it. So this isn't super efficient, but it is effective and it does exactly what we need it to do. The only drawback to selection sort is that it does not exit early. So like in our example, we had 4 and 5 already in there. It still had to run through the code until it hit the end of the array, even if it's already in there. So if it fixed 1 and all the rest was fine, it would still run the entire program over again. So let's go ahead and run ours and make sure it works correctly. Remember, we're setting it 4, 2, 5, 1, 3, 18, 0, 9, 6. And let's see. And it may take a little while. Mine worked pretty quickly, and it did sort it correctly. You're now ready to move on to the next video in sorting for the next sort style.